Hey everyone, welcome back to another episode. Today we're going to be doing a user commented or suggested video, which is registered by this person, and it is going to be procedural terrain with meshes in this tutorial. If you guys want to submit a video idea, you can join our Discord, link is in the description. I'm also going to set up a Patreon very soon, so keep an eye out for that, to help keep the channel going. Anyway, let's get right into it. So we're going to create a folder for our scripts, like usual, and we're also going to create a folder for our materials. Straight away, I'm just going to create a material for our terrain, and this is just, I'm just going to label it terrain, and we're going to give it the albedo map of a default checkered gray, and set the tiling to something like 0.2. I found that looked good. You can set it to 0.1, or anything like that. I'm also going to set the smoothness to 0. Next, we're also going to create a new empty, and we're going to be calling this chunk gen, and we're going to be giving it a new tag of type manager. And then we're just going to be setting the tag as manager. Then in our scripts, we're going to create a new script, and we're going to call this chunk gen or chunk generation. And let's open this in Visual Studio. Don't worry about this. This is my reference material, because this is going to be a complicated tutorial. All these scripts are actually available on my Patreon when I release it, for like the lowest tier. So I think it'll be like $1 or something. You guys could just get that there, and it's really simple. Anyway, first of all, we're going to make a public vector 2, and we're going to call this chunks, or chunks amount. We're just going to call it chunks, and another public vector 2, and we're going to be calling this chunk size. Then we're also going to be creating a public material, which is going to be our terrain material, and we're going to be calling it terrain mat, or terrain material. Cool. So in our start method now, we start. There we go. We're going to be starting a coroutine, and this is going to be our generate chunks coroutine. Cool. And then we're going to be creating a coroutine here. So we're going to create a public enumerator. That's how we call a coroutine, or create a coroutine, and we're going to be calling this generate chunks. Now, what is a coroutine? Essentially, a coroutine is like a void, but we can do a lot more with it. So the reason why we'll be using this is because we can add a delay between each chunk of terrain that we make. So the way our terrain system is going to work is we're going to generate these chunks here are going to determine the amount of chunks. So if you think of a game like Minecraft, the world's split off into things of sizes of chunks, pretty much, going from 0 to 120, negative 128 or whatever to positive 256. So that's kind of how we're going to be doing it here. Although we could change the chunk, we could change the chunk size, and all of that kind of stuff. But we want to keep the same, and our one is the distance between each chunk. Because then, essentially, with the chunk size, that's more just chunk resolution. So we can actually change it to resolution instead. Probably makes a bit more sense. Cool. So in our generate chunks coroutine, we're going to be creating a for loop. And we're going to be, instead of I, it's going to be X. Now, we're also going to create another for loop inside this one and set I to Z instead of I. And then instead of this, instead of the length, we can set as the chunks.x and the chunks.y. Cool. So now we're making a 2D grid of chunks or objects. And then now, before we start to get on to this next part, let's let it load. Yep. Okay, that's fine. We're going to be creating a new C# script, C#, and we're going to be calling this terrain generation. Cool. Okay, so then inside here, we're going to be making a reference to a game object, and we're going to be calling it current, and we're going to be setting it equal to a new, and here we're going to create a new type of game object, and we're going to give it the name, terrain, and then we could give it some data into the name as well. This is kind of what I like doing. So here we're going to add a bracket. And then we're going to be adding the chunks. Or actually the new vector 2. And it's going to be the x multiplied by chunk size. Or chunk resolution. Dot x. And then the z multiplied by chunk resolution dot y. And then we can be adding another bracket to end it off. Here we go. So let's just see if this works. And also, one more thing on the end, we're going to be adding the type. So also what we're going to be doing after this is we're going to be giving it some components on it. So we're going to be adding a component type of the terrain generation. The type of the mesh render. The type of mesh collider, the type of mesh filter, and the type of... Nope, that's it, I think? Yeah, it is. Awesome. And then don't forget the semicolon. And what we can do is, because we have a reference to the game object, we can go current dot transform dot position, and here we can equal it to a new vector 3, and here we're going to input a few values, and in here we're going to input x, and we're going to multiply it by chunk size dot x in brackets, by the way, and then we're also going to multiply chunk size dot x multiplied by 128 in brackets divided by chunk size or chunk resolution dot x. I'm sorry. Chunk resolution.x. Now what this is going to do is it's going to keep the chunks the same size no matter what. The position's the same. And then we're going to do the exact same thing for the z. So let's input the y, which is 0. And then let's input the z, so we can copy and paste this into here, but then change the x's for z's. So, or actually, not entirely. And we can go z, multiply chunk resolution.y, you know, multiply by that. Cool. And then we can yield a new... Oh, that's wrong. Yield, return, new. Then here we're going to input the wait for seconds. And we're going to wait for 1 frame. So we're going to input the title at delta time. Right, so essentially what we're doing in this void here is we're looping through the x and z of the amount of chunks we want to essentially make a grid of chunks. And then we're going to create a chunk object, which we're just going to be calling the terrain, sorry. And then we're going to be setting the position, and then we're going to be waiting for an amount of time. And then another thing we could do is we could also just set the parent, so we don't have, 64 extra objects floating around in the scene. So we can set the parent equal to transform. So now if we save this and go back into Unity, and we give this the chunk gen script, we want to generate, let's say, 8x8 chunks with chunk resolution of 16x16. And the terrain material, we'll just set that now to minimize annoyances later, and we click play. As you can see, it's created a lot of chunks. Now, I actually didn't know this, but it adds the brackets anyway, so we don't really need the brackets here in there. Otherwise, this ain't necessary. It's just helps. Now, if we click play again, as you can see, it's telling us these, but these are not the correct coordinates, if you will. These are not correct. The reason why is because, first of all, that has to be centered. If we click play again, let's just double check. If we go here, as you can see, these are correct. These are going well, but the names aren't, and that's because we have to do the same thing here as we have up here. We need to do the same thing as we have down here we have to up there. Instead of using the chunk resolution, we're actually just going to multiply it by 128 by 128, because that's the size of our chunk anyway, so makes it a bit easier. Now if we click play, as you can see, it's all the correct names now. Awesome. And they're all fit snug under the chunk gen object, so we don't have to worry about them, you know, being loose all over our area, our hierarchy, making it all messy. So this is actually it for the generate chunks. Now, I don't actually know if you saw, but I'll show what the wait for seconds is doing. So essentially, let's say if we do something crazy, like 64 chunks, we don't want to render the 64 chunks on one frame, or generate them on one frame. Otherwise, that's just going to be, you know, insanely laggy, especially when we're generating all the mesh for it. So here we're generating one every frame, and, you know, it's keeping up. It's still at 200 frames, but then again, we're just creating objects. Later on, we'll be creating actual chunks of mesh. So let's turn that back down to something like 16 by 16. We'll just keep it really basic. Cool, we're actually ready to start coding the terrain generation. So usually what we'd do is we'd create a prefab, and then have everything on the prefab for, to make the terrain out of. But, to minimize everything, we're going to be doing it all through code. So, making it a lot easier. So we're just going to remove everything in the terrain generation. First of all, up here, we're going to be using the system.link. This is just a reference so we can add a few extra things in our script. Also, have I done that up here? No, I haven't. Try to do that. First of all, we're going to make a reference to the chunk generation script, or the component. So we're going to call this chunk gen, just a really basic one. And then in our start method, we can get it. So we can go chunk gen is equal to GameObject dot find GameObject with tag, and here we're going to input our manager, because remember, we don't have a reference to our chunk gen when we create this when we create the chunk, and this is going on the chunk, so we need to get that. So let's then also get the component, and we're going to be getting the component of chunk generation. Awesome. Then if we're just going to check whether or not the chunk gen is actually there, so if chunk gen is equal to null, we're going to simply return, and then nothing else is going to happen. And then here we're just going to call the generate terrain. And what is generate terrain? Well, we're going to be creating another void, and this is going to be called generate terrain. And this is going to hold all our code for generating the terrain of our chunk. Awesome. Let's also make a mesh component, and let's call it mesh. Let's also create a mesh filter, and let's call it mesh filter, without caps. Let's also create a mesh renderer, and let's call it mesh renderer. And let's also make a mesh collider, and we'll call this collider. And then one last thing, let's make a list of vector2s, or not a list, a array of vector2s, and we're going to be calling this UV. UVs. So the UVs are essentially, if you've ever done something like Blender, you'll know what they are. You unwrap an object, and then you can slap textures on it and that kind of stuff, rather than just solid color. Yeah, we also need to set these components, right? So let's go ahead and do that. So if the chunk gen does not equal to null, so we can continue on with the script, we can go mesh filter is equal to get component of type mesh filter. And then we're just going to do this for the mesh renderer and also the collider. Cool. Oh, I made an extra semicolon. And then we can also assign the renderer its material. So let's call the mesh renderer dot material is equal to our chunk gen dot terrain material. Awesome. So that'll set it when we start. So in our create terrain, we're going to be setting the mesh into a new mesh. We're going to be creating a new mesh for our mesh to use as its kind of data to write into. And then we're going to be also creating a vector 3 array, and we're going to be calling it vertices. And we're going to be setting it equal to a new vector 3 array. And inside of it, we're going to be giving it an integer. And here it's going to be the chunk resolution, or chunk gen, dot chunk resolution, dot x plus 1. And here we're going to be multiplying it by the chunk. And by the way, all of this is in a brackets. Cool. And then we're going to be multiplying it by, you might have guessed it, the chunk gen dot chunk resolution dot z plus 1. And here, this is going to be the size of our vertices. And here we can also set the UVs is equal to a new vector 2 array list. And the size of it is going to be vertices dot length. And then we're also going to be creating an integer or an array of integers, and we're going to be calling this triangles. Because if you didn't know, mesh is broken up into vertices, which is the positions, and then the triangles are how the mesh is created. Because triangle is the most simple shape, which is the reason why it is rendered like that and not like in octagons or, you know, something completely weird like that. And then now we're going to be creating the vertices. So let's create a for loop. Sorry, not a float. Creating a for loop, and we're going to be setting those as x. Again, and this time the length is going to be the chunk gen dot chunk resolution dot x. And then we're going to creating another for loop inside, set them as z, and then the length of the for loop is going to be the chunk gen dot chunk resolution dot z. And inside here, we're going to be creating a float called y, and we'll be setting it equal to noise. We'll get to that later, because that's going to be creating noise in our terrain, like hills and that kind of stuff. We're going to be returning a float from this. They're going to be calling it noise. We're just creating the thing of it here now, and we'll be adding it later. We'll be inputting a float x and a float z. And then for now, we're going to be returning 0 out of the noise. But here, we're going to be inputting the x and z. Awesome. Then we can go vertices is equal to a new vector 3. And here we're going to be inputting the x and z. Now, this actually wouldn't be correct. Remember, we want to keep it the same size. So we need to do a little bit of maths as we did in our chunk generation script. But don't fear, it's actually fairly easy. Also, I forgot the y. All we're going to do is multiply it by the same thing we multiplied over here. So if we multiply it by the chunk resolution, multiply by 128 and all that kind of stuff, then we've got it. And let's just put those in a bracket so it does those first. Cool, and let's also do that to the z, although obviously instead of the chunk resolution dot x, it will be the chunk resolution dot y. Amazing. So now we've got the vertices, we've got a basic function here. Now we have to do triangles. Alright, so now we're going to be setting the UVs as we've set the vertices. Now, this is just a really cheaty way to set the UVs. We're just going to be setting it as the UV.length, as the length of the for loop. And we're just going to be going UVs of I is equal to a new vector 2. And here we're going to be inputting the vertices of I dot x and the vertices of I dot z. And it's as simple as that. That means we're getting 1-to-1 per little cube or little box. You'll see what I mean when we finish this. We're getting 1-to-1 texture per that. It's pretty simple. You could also just divide these by 2 if you really want to be able to get a more, like, zoomed out, texture coordinate system, but, this usually works perfectly for what I'm doing. Now we're on to triangles. So here we're going to be saying triangles is equal to a new, integer array, and the sizing is going to be an integer, and we're going to be, it's going to be the chunk gem dot chunk resolution multiply dot x multiplied by the chunk gem dot chunk resolution dot z multiplied by 6. And the reason why it's 6 is because per quad, so a quad is a plane, like a square essentially, it's a flat plane, there is 6 points that we need to worry about. It's because we've got 2 triangles, right? Each triangle is 3, so we need to worry about 6 points total. It sounds weird because, you know, square has 4 points, but because there's 2 triangles, each have 3 points, and we want them connected together, that would be 6 in total. We're also going to be making a integer called tries and an integer called verts. And we're going to be setting these equal to 0. Setting them equal to 0. So before we move any further, I've actually missed something critical up here. We could go actually int I is equal to 0, and then x is equal to 0. And then up here, we need to go I++. And then instead of vertices, it's vertices of I. Sorry, I missed that. If you're watching this again, remember, go back to 35 to 40 to redo that. Cool, so now we could create a for loop, and we're going to loop through our chunk resolutions. So the chunk gen.chunk resolutions .x, and all these should be x rather than I. I'm going to be creating another for loop. This is going to be z instead, and we're going to be looping through, you guessed it, the chunk gen dot chunk resolution dot z. Sorry, the chunk resolution dot y. Now we're going to be setting our first triangle here, so we can go triangles of tries plus 0 is equal to our vert plus 0. So that's the first one. And we can also go triangles of tries plus 1 is equal to our vert plus, sorry, we need to tell it's an integer, our vert, our chunk gen dot chunk resolution dot x plus 1. Sorry, I have to keep checking my my reference. This is the part I always screw up on. First of all, we could just copy these all the way down to 6. So 1, 2, 3, 4. 2, 3, 4, 5. And we could just go, the next 2 is equal to vert plus 1 equal vert plus 1. And then we could copy this for the next one. And the next one is just vert, but instead of that, it's plus 2. Then after each of these, we could go vert plus plus. And tries plus is equal to 6. Because we just added 6 triangles. And then again after this, we need to add more to the verts. And we are pretty much almost finished. We're going to clear the mesh. So we're going to call mesh.clear. We're going to be setting the vertices. So mesh.vertices is equal to vertices. Mesh.triangles is equal to triangles. And mesh.uv is equal to uv. And we're going to recalculate the normals. So mesh.recalculate, not bounds, the normals. There we go. We could also recalculate the bounds of the mesh. And then mesh dot, actually this is the collider, shared mesh is equal to mesh, and the filter dot mesh is equal to mesh, and the renderer, oh, we've already set the renderer material, and this should be it. Now we just need to add the noise afterwards. So let's go, click, there has to be errors, of course there is. And number 31, yup, vector 3, that's y instead of z. There'll be another one. Yep, knew it is. 36. chunk resolution instead of Z, it's not Y. Chunk resolution. 38. That's chunk gen. Dot chunk resolution. Same over here. Chunk gen. Dot chunk resolution. And then chunk gen. Dot chunk resolution. And chunk gen. Dot chunk resolution. Cool. Another one. 47. Chunk resolution dot Y. I always do Z instead of Y. I probably need to change up my terminology. 47. Put the rest in brackets after the int. And then 54. Spelt it with 1 instead of, okay. Cool. Oh my god. How many? Yep. 55. Put those in a bracket. And then it's not filter, it's mesh filter. There we go. And we are done. Watch there be errors. No, we got it, but oh shit. Done something wrong. I have just realized that I've used Y and X opposite here in my reference, so I'll just see what that does. Probably won't do anything, but we'll see. Oh, in our vertices, we actually weren't supposed to have this. That's right. Cool. I think I ran into that issue before as well. That expected 38. We're at 38. Awesome. Let's play. Cool. Now it's generating a bit smoother, but you know, we still got this happening. Let's just turn on selection Y to see what's happening. Alright, it seems like it's stretching a lot of the vertices, and isn't setting the Z properly on them. It's setting the X correctly. Oh, sorry, it's setting the Z, but not the Z on this side down here. On the X, so... Oh, it's less than or equal to. There we go. Found it. There we go, and as you can see, it's generated it. Now, it's generated like this. No idea why. I don't know how to fix it though. All you gotta do is go mesh dot triangles is equal to mesh dot triangles dot reverse not reset dot to array. Oh. Dot to array. And here we're just flipping all the kind of vertices, which in turn kind of flips the normals of them. And as you can see, now we generate this beautiful structure. Awesome. We finally got it. I'll go over literally all the code when we're finished. Give like 10 minutes to do that, because I know it's been kind of complicated, kind of like a brain freeze. It even's brain frozen for me, and I coded it. So yeah. But yeah, we have a pretty nice looking terrain, and as you can see, it's like that. If we wanted to turn down the resolution or up, we could just change these to something like 8x8 instead, and then we would still get something like this. As you can see, they're a bit more, it's a bit less packed together, and a lot less in each chunk. Let's just set this back to 16 by 16. 17 by 16, no, 16 by 16. Cool, so now in here we can actually give it some noise. So instead of returning 0, we can return Y. Now we can set Y, float Y is equal to mathf.perlinnoise. And here we can input the X and Z. However, the X is going to be multiplied by our good and trusty, multiplied by chunk resolution. That chunk right there. Sorry, multiplied by the 128 version of it. Not the entire version. Let me get that again. Multiplied by the 128 divided by chunk resolution.x. Actually, no, we're just taking this whole thing. So we're gonna be, well, for the X part of the Perler noise, for the vector 2, we're going to be inputting the X multiplied by chunk resolution .x multiplied by 128 divided by chunk resolution .x. But plus the transform .position. We're doing it the same thing here, but instead of the X and Z, chunk resolution .y, not Z. And then plus the transform .position .z. Cool. So now we can put both of these, all this in brackets for each one. And then we can multiply by, let's say, 0.02 for some more finer noise. Multiply by 0.02. Multiply by 10. And then let's add some really big hills. So y plus equals to mathf.Perler noise, but instead of doing that, we'll copy the whole thing of this. Chuck it in here. 005 or 006 will go. And then instead of 10, we'll do something more like 70, so it's really exaggerated. And then we're returning y for the noise. And then how do we set this? Well, I think we already have. Float y is equal to noise, and we input y there. Awesome. Chunk resolution 80. Chunk gen dot chunk resolution. Copy this for each of them. Awesome. 80. Transform.position.x. Awesome. Click. Back into Unity. By the way, remember this is like minimal options. We're not really doing it. We're not really having to do anything in the inspector. And if we click play now, as you can see, we have some very exaggerated noise. And when I say very exaggerated, I mean like insanely exaggerated noise. And also they don't line up at all. So it's a bit iffy. A bit iffy. Well, we can fix all of this though. So let's actually remove the start chunk resolution, because we're really only multiplying by the second one to be able to get the true position. And also put these in brackets first, so it's done first. Order of operations, baby. And let's click play. And as you can see, we have terrain! Look how beautiful this looks. Beautiful terrain, and it actually is very nice and playable. Now, you could add, you know, as much... this actually looks really cool, by the way. It looked better than what I did in my tests. You know, you can add some texture instead. You can also set, like, you know, tiling a little bit low so you can make out what the shape of it is better. Tiling, let's say, like, 0.1. Oh, wait. 0.1. 0.1. You know, you can make out the shape of all the hills a bit better because of the UVs and that kind of stuff. But I say this works pretty well. Let's go over all the scripts. This isn't a necessary part if you just wanted to know how to code it. That's all you came for. You can end it. Otherwise, skip to the end. Otherwise, now, stay for a bit. Cool. So let's go through it. So in the chunk generation, we're making a polling vector 2, which is how many chunks we're having from the X and Y imagine it's kind of like a flat plane, and the X and Y is just how many chunks you're going to have. Cool. Chunk resolution is how many vertices on each side of the chunk. Public material, well, that's just, you know, the actual material of the terrain, which is, in our case, is our terrain material here, which has just got the checkerpoint texture on it. Then in our start method, we're calling the coroutine. We're starting the coroutine, which is creating the chunks. We're looping through the X chunks and the Y chunks, creating a terrain chunk for each one of those and setting it to the correct position, and then we're waiting 1 frame before we go on to the next chunk. Going into our terrain generation, at the start, we got the chunk gen, we got the mesh filter, mesh render, collider, and UV. And then in our start method, we're setting the chunk gen. If chunk gen is equal to nothing, so if this doesn't exist somewhere in the scene, which it should, otherwise, if nothing's generating, just check your thing has the manager tag. Setting the mesh filter, setting the mesh renderer, setting the mesh collider, setting the mesh renderer material. Then we're generating the terrain. Now on the generating terrain, we're making the mesh. We're making a blank mesh to be able to write data onto it. Creating the length of the vertices, creating the length of the UVs, creating the triangles, not setting them yet. Then we're for looping through the vertices, the chunk resolutions to get the vertices, and then we're setting the Y value with the noise down in this function here, and we're setting the vertices X and Z and Y value, and we're writing the data into our vertice array in here, and then down here we're setting the UVs, triangles, we're setting the length of the triangles. These two are kind of like constructors for this. For looping through the resolutions again to create the triangles for the vertices. Clearing the mesh, setting the vertices, setting the triangles, setting the UVs. Recalculating normals. Now normals is to do with lighting and how light works upon an object. And it also helps, so if you had flipped normals or flipped triangles or whatever, you can flip them here so that you can actually see the object, rather than having it down the other way. Recalculating bounds, this is for the collider. I don't know why you need to recalculate bounds. I'm guessing that's to figure out what the mesh should look like in the mesh collider. And then the mesh filter.mesh, we're going to set that equal to our mesh. Then down here in the noise, we're just setting our Y with parallel noise. And then we're returning Y. I hope you guys enjoyed this video. If you did, click the like button. Go down and check out our Discord, link is in the description. Now, right now, this is one last thing extra for experts. If you guys want to have this completely random, because at the moment it's not, we can actually add a few things. So here we go. I thought I was done, but I forgot about the seed. So here we're going to make a public integer, and we're going to be calling it seed. The start method, we can just set this as something random. I'm not going to, because I want to make it user inputted. But here, in our noise, we can actually change this up based on our seed, right? So in here, after all this, x plus, another bracket, x plus the chunk gen dot seed. And here we could just copy this, set an x there, we could paste in the x. And instead of there, that's x to z, x to z. Here we go back into Unity. Now we go into our chunk gen, let's change the seed to something big, like, 246. Something a bit random. As you can see, it's generating this. Cool, that looks pretty cool. Now let's change it to something, 1000. And as you can see, you probably can't see, it all looks fairly similar. But it is different this time. Because we're adding onto the noise to be different. You'll see bigger notices at like something like 8,000 blocks, 8,000 distance, because it'll look very different. Yeah, that starting looks a bit different. That kind of stuff. Anyway, hope you guys enjoyed. Join the Discord. Don't forget to subscribe, hit the like button, and I hope you guys have a wonderful day.